Hey everyone, welcome back. In this lesson we're going to still work on some of the things that we've been doing in the last few videos, but we're going to add a level of complexity to it. So what we've done in recent videos is we've been working algebraically with a single variable, with one variable, and we've been trying to solve for what that variable is. Now, you saw at the tail end of that sort of subtopic in our algebra unit, that there were some questions where we had to find two different values, right? Like if we were looking for two different numbers whose sum is some number and one value is this much bigger than the other, then sometimes we were trying to figure out two different values, but we were only working with one variable, right? So what you can do is you can expand on that idea, and we'll begin working with two variables in this video. So there'll be just a couple of things that I'm going to point out at the start, and then we'll go through some examples so you can see how this sort of works in practice. So this one is going to be working with two variables. Alright, so in this one we're going to be focusing on just the subtle differences between working with one variable and two, and then we'll go through, I think I have 3 examples written out here. We'll see if we can get through all 3 of them in this one. If not, we'll start working on those in the next video. We'll definitely start them today, I just don't know if we'll get through all 3 of them in this one. Yeah, I don't know if I'm going to focus too much on word problems for this side of for this sort of subtopic, just because it is a little bit more complicated already, but we'll see if we can throw in some word problems a little bit later on. We're going to do plenty of practice problems involving two variables. So basically the way that you can try and solve this is try to turn it into a one variable problem. So even though in the problems that we've been working on so far it may have looked more beneficial to add in a second variable, in order to actually solve it, it's usually best to try and turn it into a one variable problem. Alright, so what that means is if you've got x's and y's kicking about in your equations, try and get rid of one of them by describing it in terms of the other. So for example, if I told you, I'll just do a quick run through here and then we'll examine it more closely when we're doing the examples, is if I told you x plus y, so two numbers, we'll call them x and y, if you add them together you're going to get 10. So what I'm telling you is, like, this would be something that's given to you in the question, like equation 1 is x plus y is equal to 10, and then I'm also telling you that y is 2 bigger than x. So x is smaller than y by 2 units. So I could write that as sort of an equation 2 over here, which is that y is 2 units bigger than x. So if we're saying they're both integers or whatever, both whole numbers, we've got x plus 2. And maybe we have the knowledge going into this question that they're going to be integers, they're going to be whole numbers, and so x, some number, plus 2 is going to equal y. And that's all the information that will have been given. And then you can use those two equations in combination with one another to actually solve for x and y. So you could just sort of try and brute force it, like, you know, just sort of try groups of numbers that you know will add to 10, so like 2 and 8, or 3 and 7, or so on, you know, things like that. Or you could work through it the way we're going to actually work through it, so that you don't have to just guess a million different things to work through the problem. Now, the thing you might notice that's slightly different here is that before, when we were working with just one variable, we only had one equation, right? And we were just solving for x based on that equation. And here, you'll notice that we've got two variables and two equations. Now, that's no coincidence. The number of variables you have that you need to solve for is going to be the same as the number of equations you have to work with. At least that many equations you have to have if you want to solve everything. So basically, if you have two variables, x and y, you need at least two equations that relate them to other quantities or relate them to each other in order to be able to actually solve for x and solve for y. And similarly, if you had three equations, we're not going to really worry about that in this unit, or perhaps in this course at all. But if we're working with three variables like x, y, and z, then you need a minimum of three equations in order to solve for all three of them. If you don't have three equations, you might be able to solve for one thing, but you wouldn't be able to solve for the others. With that in mind, we need, if we're working with two variables, I'm going to get rid of this example, we're going to do something not overly different from it. Basically, we need two equations no matter what. As long as we're working with two variables, we need two equations because we have two variables. Okay, so we need two equations because we have two variables. Alright, so if we've got two quantities that we want to solve for, or that we need to solve for in the problem, we need a minimum of two equations. I could give you more. I could give you more information that you could use. If I gave you, like, if you only had two variables but three equations that are all connected, then you could use any two of those equations. So like any pair of equations from that group of three in order to solve for the variables that you need. So it doesn't have to be exactly two, it just needs to be at least two. I could give you 10, but you could just choose which ones you wanted to work with from there. Alright, so in order to solve for two different variables, we need two equations. So with that in mind, just so you guys can see some of the actual math in this video itself, we will jump right into our first example. And when I was writing these out before, I numbered the examples 1, 2, and 3. I'm going to do the same thing. I'm going to get rid of the title for now. I'm going to do the same thing, but I'm going to use Roman numerals, so I, and I, to label the problems, just because you'll see when we're working on the actual question. So problem number 1. So I'm using Roman numerals to denote what question we're on. So for this one, I'm giving you two equations. Equation 1, this is where I'm using actual numbers, like the numbers that we're used to give you your two equations. So your first equation is 3x plus 2y is equal to 11. Okay? And your second equation, because we need at least two equations to be able to solve for two variables, is 3y is equal to x. Alright, so how do we work through a problem like this? Well, the goal here is we want to use either equation. It doesn't matter which one, but one of them will usually be easier to do this with. And we want to have it so that one of the variables is all by itself on one side of the equation, and everything else, numbers and things with the other variable, are on the other side of the equation. So if you remember when we were working with just a single variable, so if it was like 3x plus 4 is equal to 16 or something like that, then we wanted to get this x all the way by itself. We wanted to work through steps going all the way down to just having x by itself on one side and all the numbers on the other side. So, first we would subtract the 4, and then we would divide by 3. We'd end up with x is equal to, let's see, what do we have here? 16 minus 4, that would be 12. And then dividing that by 3, you should get x is equal to 4. Right? So then here we would have 3 times 4 is 12. Yeah, so you should be able to get something like x is equal to 4 by getting rid of the numbers step by step. So up here, with either of these equations, we want to get rid of one of the variables by writing it down completely in terms of the other variable and some numbers. So what that means is we want just x equals something. We don't care what the something is as long as there are no more x's in it. Or we want y equals something, and we don't care what the something is as long as there are no more y's in it. So for this particular question, that's already been done for you, because if you look at your equation 2 over here, we already have x equals something, and this thing over here doesn't include any x's, so we can just use that. Now, what we're basically doing is we're going to take this relationship. We've got x is equal to 3y. 3y is equal to x. And we're going to sub that into the first equation. So I'm subbing in, and the way you would write this is sub equation 2. So you could write EQ or EQN for equation, or you could just put this 2 with a circle if you've labeled the two equations. So sub equation 2 into equation 1. And so what that's going to look like is basically we're going to rewrite equation 1, what we have up top here. So we've got our 3x plus 2y equals 11. So don't write this down just yet. So let's rewrite that equation to start with. So we've got 3x plus 2y equals 11, but that's just what we started with. We haven't subbed anything in yet. The subbing in comes right now is that we know x is equal to 3 times y, or 3y. So what I'm going to do is anywhere I see an x down here, I'm going to get rid of it, and I'm going to replace it with what x is equal to, which in this case is 3y. So here, instead of getting 3x, I'm going to have 3 times 3y plus 2y equals 11. Alright, hopefully that's making sense. So this thing right here used to be x, and I've replaced x everywhere that I see it. In this case, it's only showing up once, but I'm replacing it everywhere that I see it with the thing that it's equal to. So now I've got 3y in brackets here. So then if I rewrite that out, I'm going to just do the multiplication. 3 times y, that's going to be 9y plus 2y is equal to 11. And so now you can see we've got everything in terms of just one variable. It doesn't have to be x every time. This time we've got it in terms of y. So if we go ahead and do this addition, we already did the multiplication here. 3 times y is going to give us 9y there, plus 2y equals 11. Adding those two together, we get 11y equals 11. So that's going to tell us that y is equal to 1. Right? Because 11 times what number is going to give you back 11? That's what this thing at the bottom is asking us. 11 times what number y equals 11. So y has to equal 1. Or the other way you could do it is you could divide both sides by 11, and you'd be left with y equals 1. Now we're almost done the problem, but we're not completely done. So we know now what y is equal to, but we still need to figure out what x is equal to. Right? So far we've done half the problem, we've solved for y, but now, so we used equation 1, right? For the most part, we were working with equation 1. We subbed in a little thing here and there, but for the most part, this thing looks a lot more like equation 1 than it does like equation 2. So we basically used equation 1 to get y, so we're going to use equation 2 to get x. We're going to use whichever equation we haven't used yet to find x. So in order to do that, well, I know 3y is equal to x. I know 3y is equal to x, right? But I also know from the first part of the problem that y is equal to 1. So I can go ahead and I can just write in 3. Instead of writing in y, I'll write in a 1. We know it's 3 times 1 because y is equal to 1. We already know that. Is equal to x. So that tells me that 3 is equal to x, or x is equal to 3, however you want to write that down. And there you go. There you have your final answer for both variables. In this one you get that x is equal to 3 and y is equal to 1. And it's always good practice at the end of the problem to just go back. I'm going to sort of section this off a little bit from the rest of it. It's also good practice at the end, just like when we were working with one variable, to sort of backtrack at the end and plug your numbers back into the equations that you started with to see if all the numbers check out. We could do that here. So x is equal to 3. So that means let's say if we used equation 1, then that means it would be 3 times 3 plus 2 times 1 is equal to 11. 3 times 3 is 9. 2 times 1 is 2. 9 plus 2 is 11. So it would check out using the first equation. And let's just say for the second equation we use the same thing, so we can check that out there as well. So 3y is equal to 1, and x is equal to 3. 3 times 1 is equal to 3. That part checks out as well. So you can always just plug in those numbers the same way we did when we were working with one variable, just to see if the numbers make sense, to see if you can get the same number on both sides of the equal sign. Alright, hopefully that didn't go too quickly. I'm going to erase this problem. I'll leave the 1 and the 2 there. I'm going to put in new equations there. Alright, so hopefully that problem made sense. If it went a smidge fast, I apologize. We're going to do 2 more in this video itself, so hopefully you'll see plenty of different examples before I let you go today. So let's move on to problem number 2, example number 2. So in this one, our first equation that you're given is 14x minus 4y is equal to 12x. Okay? And the second equation that you've been given is y plus 2 is equal to x. So basically what this is telling us is x is 2 larger than y, right? Y plus 2 means it's 2 larger than y. So x is some number that's 2 bigger than y. And we also have this sort of mess up here. We've got x's on both sides, which is a little bit of a problem. So let's actually deal with that problem first. What I'm going to write down here is we're just going to rearrange equation 1. And so what we're going to do here is we're going to try and at least get all the x's on one side and all sort of grouped together as best we can. Because right now, it's not we haven't written it the simplest way that we possibly could, right? So let's go ahead and do that. So if we wanted to if we wanted to get all the x's on one side, so let me just rewrite what we started with. So we've got 14x minus 4y is equal to 12x. Now I could bring the 12x over here by subtracting 12x from both sides, right? I'll subtract 12x from here, and I'll subtract 12x from there, which will leave me with 0. So then what I end up with is 14x minus 12x, right, because we're subtracting that, minus the 4y that we originally had, equals 0. Right? Now I can go ahead and do this subtraction right now. 14x's minus 12x's is going to leave me with 2x's minus 4y is equal to 0, right? But I don't want to have a negative sign if I can avoid it, and maybe it's not the most beneficial thing for me to have the x's and y's both on the same side. So what I'm going to do is I'm going to take this negative 4y, I'm going to chuck it over on the other side and make it positive 4y. So I'm going to end up with 2x by itself on the left side equals 4y on the right side. Alright, hopefully you can read that down there. So we've got 2x equals 4y. So I've taken this negative 4y and I've chucked it over there. The sign flips, so it becomes positive 4y when you throw it to the right side. And I'm just going to do one last step. I'm going to sort of throw this over here and then erase some things so that we can free up some room. So here we've got 2x equals 4y, but both of those numbers, so both of those quantities are divisible by 2, right? I could divide the left side out by 2, and I could divide the right side out by 2. So if I divide the left side by 2, I'm going to be left with 2x divided by 2 is going to be just x. And on the right side, I've got 4y divided by 2. So 4 divided by 2 is 2, and then I just leave the y untouched. So that gives me x equals 2y. So what I'm going to actually do right now is, let's see, how do I want to do this in the easiest way possible? Whatever. Alright, so what I'm going to do is I'm going to erase what we started, not what we started with up at the top, but what we started with in our rearranging of the equation. And what I'm going to do is I'm going to call this new relationship that we've got here, x is equal to 2y, I'm going to call that equation 3. Okay, so we're going to construct our own little equation 3. So x is equal to 2y. That's the relationship we got by rearranging 1. So since we've used equation 1, I'm going to put a little star there because we don't really need to use it over and over again. Now we can use equations 2 and 3. You can see equation 3 is way simpler than equation 1 that we started with, right? So I'm going to use equations 2 and 3 to actually find the values of x and y. So to do that, well, I know x is equal to whatever y is times 2. So in order to solve for x, Well, in this equation I've got x by itself, and in that equation I've got x by itself. So you can choose whichever one you want to sub into the other one. I'll sub in equation 3, so I'll sub equation 3 into equation 2. So what that's going to look like is I rewrite equation 2. So I've got y plus 2 equals x, but don't write the x because we want to do that substitution. We want to take this relationship right here and throw it in place of that x right there in equation 2. So if we want to do that, instead of having y plus 2 equals x, well, we know x is equal to 2y. So I'm going to get rid of that x and I'm going to throw in a 2y down there. Okay? So now what this lets us do is this lets us solve for y, and then we can go back to one of the other equations and solve for x. So since we're subbing this into equation 2, I'm going to put a little star beside equation 2 because we're using that one now. So if I wanted to get the y's by themselves, I'm going to throw this y to the other side. We get 2 is equal to 2y minus y, right? When we take this y over to that side, it becomes negative y. So we've got 2y minus y. So that tells us y, that's all we're left with on the right side, is equal to 2. Simple enough. So that's told us y is equal to 2. So we're almost done now because we know one of the variables and we have an equation left over that we haven't used to find the other variable. So what we get from this calculation here, when we subbed equation 3 into equation 2, is we got that y must be equal to 2. And now we can go ahead and use, well, we've already used equation 1 because we rearranged it to get equation 3 down here. Then we used equation 2 to solve for y down here. So now let's use equation 3 to solve for x. So we know x is equal to, I'm just going to section that off again. So x is equal to 2y, right? Well, we know y is equal to 2. So we get x is equal to 2. Instead of 2 times y, we'll write it as 2 times 2. And we know 2 times 2 is equal to 4. So we get x is equal to 4. And that's it. And so then you have x is equal to 4, y is equal to 2, and everything works out. And then you can go back, don't plug it into equation 3 necessarily, because that's one that we came up with ourselves. But if you wanted to check your answer, plug it back into those first 2 equations that we were given at the beginning. So you could plug in y equals 2 over here, and x equals 4 over there, 2 plus 2 equals 4, and you have 4 on that side, so you can check to see that that works out. And it's a little bit messier, but you could plug it in up here as well. 14 times 4 is 56. Yeah, 14, 28, 56 over here. 4 times 2 is 8, so 56 minus 8 is 48. And then 12 times 4 is 48 on that side. So you can check it using either of those equations. It should also work if you use equation 3. I just recommend against it because that's one that we came up with. So if you happen to make a mistake and you check it against equation 3, equation 3 might have been where you made the mistake. So always go back to the stuff that was given to you in the question wherever possible. Alright, hopefully that's making sense. We're cruising right along, hopefully. Let's jump right into our last and final problem of the day. This is going to be example number 3. So remember, you got to solve for both of them. Since these aren't word problems, you don't have to be super particular about like leaving like a therefore statement or writing let statements or anything like that. That's when you are labeling the variables yourself. And the person who's reading it might not understand what the variables stand for, so that's why we would make our let statements there. For the problems like the ones we're doing, if you just box your answer in at the end and you say x equals blah blah blah, y equals blah blah blah, you should be fine. Alright, so last example. So here we've got 2 equations once again. So the first one is going to be 22x minus 3 is equal to 7 times y. 22x minus 3 is equal to 7 times y. Alright, and the second equation that you've been given is y equals 2x plus 3. So slightly more complicated than before, but not that much more complicated, because if you look at this, it's sure neither equation looks quite as simple as like the x equals 2y kind of stuff that we were getting from before, but we've already been given an equation that solves for y, that's written y in terms of just things that involve x and numbers and no additional y's on the other side of the equal sign. So what we're going to do is we're going to jump right into this. We're going to sub equation 2. We don't have to rearrange anything. We'll sub equation 2 right into equation 1. So if we're doing that, let me rewrite equation 1 first, and then we'll erase some stuff. So we've got 22x minus 3 is equal to 7 times y. But we know that y is equal to 2x plus 3, right? If we're subbing this equation up there, then I can replace the y up there in equation 1 with this 2x plus 3. But you got to be careful here. Make sure you put it in brackets. 2x plus 3. The reason we're putting it in brackets is because y equals this entire thing, and it's 7 times y. So it has to be 7 times this entire thing. Now, we talked about this briefly before, that whole distributive property. So we're going to take this 7 on the outside, we're going to multiply it by the first term, and we're going to multiply it by the second term. And since there's an addition sign in between, we're going to add those two answers together. So we're going to leave the left side exactly the way it was, so 22x minus 3. And then on the right side, well, for the first term, it's going to be 7 times 2 times x, right? So, well, basically 7 times 2x. So 7 times 2 is 14. So that'll be 14x, right? The x comes along for the ride. And then there's a plus sign in the middle, so we're going to add them. And it's going to be 7 times 3, right? 7 times 3, which is equal to 21. So going through the distributive property there, we get 14x plus 21 on the right side by solving, or sort of by expanding out this thing, the 7 times, in brackets, 2x plus 3, close brackets. So now we've got an equation down here that's entirely in terms of x's and numbers. So we can use that to solve for x. So I'm going to take this 14x, I'm going to bring it over this way, so that I have all the x's over here. And I'm going to take this negative 3, I'm going to chuck it over there, so that I have all the numbers over there. So then I end up with 22x minus 14x, remember it's going to be subtracted when you bring it across the equal sign, equals 21 plus 3. And it's added because it was originally being subtracted, so we flip the sign when it goes to the other side. It was negative here, so it'll be positive there. And for the 14x, it was positive there, so it'll be negative over here. So then if we go ahead and solve for that, 22x minus 14x, that's going to leave us with 8x. 21 plus 3 is equal to 24. You can divide both sides there by 8, and you should be left with x equals 3 as your final answer for x. Okay, so we've used equation 1 for the most part there, right? We subbed this second relationship into equation 1 to solve for x. So now we'll just box this off, and over here we'll use this remaining space to solve for y. And so to do that, we're going to use equation 2. So we've got y is equal to 2x plus 3, but we know x is equal to 3 already. So we can sub that right in. So it'll be 2, and then instead of writing 2x, I'm going to write 2 times 3 plus 3 is equal to y. So then if we just go ahead and calculate that, 2 times 3 is 6, plus 3 is 9. So we get y is equal to 9. Alright, so hopefully that makes sense. We've got for this one, x is equal to 3, y is equal to 9. You can go ahead and double check that that makes sense with the example that we have up here, or with the equations that we have up here. If x is equal to 3, then this would be 2 times 3 is 6, plus 3 is 9, y would be 9, and if we use it with that one, that'll be 66, 63, 63, yeah. So it should check out with both equations, so you can go ahead and work that out if you want to convince yourself that x is indeed 3 and y is indeed 9 for this particular question. But yeah, so that's basically how these systems of equations work. So it's like two equations that are linked together. So the x in the first one means the same thing as the x in the second one, and the y in the first one means the same thing as the y in the second one. So those two equations are connected to one another in this system of equations. And again, if you had more variables, you would have more equations. But yeah, you need 2 equations minimum if you're trying to solve for 2 different variables. And so now we've gone through a few examples, so you can hopefully get a better idea of how that stuff actually works. But yeah, so hopefully this is all making lots of sense. If not, get in touch with me. You have my contact information. Otherwise, I will see you in the next video. Have a good one.